Today we're at the Cliff House and we're talking about soil movement. And after the 13th atmospheric river in California this season, we're having to think a lot about how our houses move on top of the soil. So let's get into it. Today we're talking to Juan Flores, the project manager of the Cliff House. And Juan, you and I have been working together for a long time, and we've seen a lot of projects where we walk into a house and things just don't look right. And this was one of them. Can you explain a little bit about what you saw when we first walked in here?
Yeah, sure. Just really when we start the project, we see significant slide out the portion of the floor, which is, means unlevel. And this is basically expansion and contraction of the soils.
Okay. So this portion of the house is level, but then this portion actually slopes down towards the water.
Correct.
Okay. And so what we really looked at was how this was built. And we figured out that this was actually the backside of the house in the original house, and that this was an addition. And they have a different foundation. And this foundation really wasn't built correctly, and it's moving now, even though the rest of the house is fairly stable.
Most likely, yes.
Okay. And so this isn't really the first time we've seen this in a lot of our projects, right? A lot of our projects, we see a lot of things that let us know that, in fact, the ground is actually moving around a lot. What are those things that you're seeing in the projects that kind of let you know what's going on?
Well, there's a lot of different things that, let you know that something's happening with the movements, which is like the doors and the different seasons. You can open the doors in the weather.
In the summertime?
Summertime and wintertime. Sometimes you can open it, even the doors, windows, also cracks in the ceilings. On the joints between the walls and ceiling.
Okay. And so that's being caused by the house moving with the soil, right? So
correct.
What we talk a lot about in this area is that the Silicon Valley used to be orchards and farmland. And a lot of that organic material when it was being developed for houses, all the trees and the plants just got buried in the ground and they turned into clay. And that clay absorbs a lot of water. And so when it absorbs water, it expands and it kind of grows. And then when it dries out, it shrinks. And so the house in the seasons is kind of moving up and down. But I think what's really important is also that it's not necessarily moving in the same place in every portion of the house. So some place it may not move at all, and other places it's moving a lot.
Yep.
And so what we see is that a door that we can open in the wintertime, we can't open in the summertime. Or that we have windows that are perfectly good in the wintertime, but they're jammed because the house is essentially moved like this and racked that opening. So now we can't open those windows in the wintertime. And so what we're looking at is trying to stabilize those houses. And what we have to understand is that the whole root cause of that problem is that the houses that they built in the 50s and 60s, when the majority of the houses in the Bay Area were built on what are called footing foundations. And so they're sitting on top of that expansive soil. But we know that now we actually have to do a geotechnical report. And we spoke earlier about geotechnical reports where an engineer will come out and they will hire a company to drill a core. So essentially take a core sample down to typically 15 or 20 feet. And they'll take that core of dirt out that describes all the different layers of dirt in that core, and they'll send it to a laboratory. And when they send it to a lab, they get back a physical characteristics of that soil in that column. And that tells them what's the underlying soil. And they can then say, well, we have 8 feet at the top of the ground that's expansive soil. And so if we want our house to perform well and not to move around with the rains, then we have to get below that. Now, the option is we could dig a big basement and get below that expansive soil, but that's really expensive and a lot of houses don't want basements. Or we could use something called a pier and grade beam system. And a pier and grade beam system for our foundation is large cylindrical piers which are drilled into the ground, so they make an excavation in the ground. And then a structural engineer will tell us how we have to fill those piers, those columns or cylindrical holes in the ground with rebar and concrete so that we now get to the soil below the expansive soil that's stable. And then we build that column. So it's almost like a pier when the pier is going through the water, and you can kind of think of the water as the expansive soil and down into the bedrock at the bottom of the ocean or the lake. And so our house is kind of floating on these piers, and the soil is moving around up and down, but the house is actually steady.
Yes.
Right?
Correct.
So why don't we do that to all projects? Why aren't we just drilling piers for all projects?
Because it depends on the soils.
So sometimes we don't need to do that.
Exactly.
Okay. And unfortunately, it's also really, really expensive. And it's difficult to get the equipment into, say, a hillside lot to drill those piers, because sometimes they go 15 or 20 feet down.
Right, yeah.
And then we have to build a special foundation for those. So if we can avoid doing that, we will avoid doing that. But really, the geotechnical engineer is deciding what the type of soil we have is, and then they give that report to the structural engineer, and then the structural engineer designs the foundation for your house.
Correct.
Now, we've actually done projects, including my own house, where we actually had to put in a whole new foundation around an existing house, because the original builders didn't build it with the piers deep enough. So it did have piers, but those piers only went 4 feet deep, and that was still in the expansive soil phase. And so the house still moved around a lot. And I can remember when I was playing with my kids once, and I rolled a marble across the floor, and it rolled into a corner because the house had been moving around with the soil. And so the structural engineer required us to drill down through, actually the geotechnical engineer, through that expansive soil, and then put piers. And I had to put 15-foot piers around my entire house to put a second story on. So it's not just new houses, it's existing houses. Right. And then a project like this. So now we look at this project and we think, okay, well, we know that we have a slope down here, and we know that the ground is moving around here. Is it just a default decision to put a pier and grade beam foundation around here, or are there consequences that we have to think about?
Yeah, there's definitely different consequences that we can think about it before we come to adding more piers.
Okay, and so if we were to say put that pier and grade beam foundation in here and kind of isolate that footing, I know we notice we have a big steel beam over here. Like, what happens when that portion of the house stays stable and this portion of the house moves around a lot? Like, what's going to happen to the area upstairs?
It's going to crack and move towards one side. I mean, depends on the move of the foundation.
So we could end up getting sheetrock cracks or flooring cracks or tile cracks or even window and door cracks.
Window cracks, yes, correct.
So is it generally better to leave these portions of the house independent of each other so that the house is kind of moving? Because we know that the house is stable here, but if we add additional structure where we're not told to by a structural engineer, we could effectively cause problems that didn't exist before, right?
Yes, correct.
Okay,
Correct.
so it really makes sense for us to think about where we're spending money, to depend on structural engineers and geotechnical engineers to give us reports, to tell us how we're investing money in this project, and to make sure that we're not causing problems that didn't exist before by trying to solve other problems that may not have really been causing any appreciable problems for the homeowners. Building a better way is about building the best project you can for that site. It's about paying attention to structural engineering and geotechnical engineering. It's about considering architecture and building performance. It's about building the best house you can in the most cost-effective way. If you're interested in following more about this project or other projects, or in general learning more about building science, hit subscribe as we show you how we build a better way.